That night in northern Australia, an entire city could only hear three things: the howling of the wind like it was screaming, the roaring vibration of rooftops about to tear off, and the crack and snap of trees breaking in the dark. Within minutes, Darwin plunged into widespread blackouts. Waves offshore rose like walls of water, and severe Tropical Cyclone Fina, a wind monster of more than 200 kilometers per hour, was passing right outside people's windows. Now forget Australia for a moment and think about your own city. If all of this happened where you live, what would you do in the last 10 minutes before the storm hits? Welcome to Global Weather Disasters, the channel that not only shows you terrifying storm footage, but helps you understand why these events happen and how you can protect yourself. In this video, we'll go straight into the story of Cyclone Fina over Darwin in November 2025, the key timeline of what happened, the mechanisms that allowed it to intensify so close to land, and the real-world lessons for anyone living in cyclone-prone regions like you. In mid-November 2025, a tropical low formed over the warm waters between the Arafura and Timor Seas, north of Australia. Within a few days, the system became better organized, was named Tropical Cyclone Fina, and quickly strengthened to Category 2 as it approached the northern coastline. The Australian Bureau of Meteorology began issuing cyclone warnings for coastal areas from Cape Don and the Tiwi Islands, later expanding the watch zone to include Darwin, as forecast models showed the storm tracking closer to populated regions. By 22nd November, Fina had intensified into a severe tropical cyclone Category 3, with sustained winds near the center around 150 kilometers per hour and gusts over 200 kilometers per hour. The center moved slowly southwest, skimming close to the Tiwi Islands and bringing heavy rain, high seas, and destructive winds. That evening, radar showed the most intense core of the cyclone sweeping through Van Diemen Gulf, just tens of kilometers north of Darwin. Darwin International Airport was closed, supermarkets shut down, buses stopped running, and evacuation centers opened. Residents were urged to go home, shelter in place, and prepare for power outages. During the night, trees were uprooted, roofs were torn, roads flooded or became choked with debris. Around 19,000 customers lost electricity. By the following morning, Fina had moved away from Darwin into the southern Timor Sea, continuing to intensify before weakening as it approached the Kimberley region. The city suffered notable physical damage, but fortunately, no major loss of life was reported. Tropical cyclones are giant heat engines that draw energy from the ocean. Three main ingredients helped Fina intensify warm and deep sea surface temperatures, moist and unstable air, and relatively low vertical wind shear. At the time, the waters north of Darwin were very warm, with a deep warm layer, creating an ideal fuel tank for the storm. Fina moved slowly across this warm pool, giving it plenty of time to extract energy while the sea surface did not cool significantly. Higher up in the atmosphere, outflow channels were working well, allowing air to evacuate from the top of the storm, while wind shear was not strong enough to tear the cyclone's structure apart. Put together, this environment allowed Fina to strengthen quickly from a relatively modest system into a Category 3 cyclone, then push close to Category 4 as it moved away over the Timor Sea. What made Fina particularly noteworthy was its timing. The cyclone season in northern Australia officially runs from November to April, but historically, the strongest storms tend to occur later, from December to March. A Category 3 system passing so close to Darwin in November is considered rare over the past couple of decades, hinting that the edges of the season may be stretching in a warming climate. Climate studies worldwide suggest a worrying trend. The total number of cyclones each year might not increase dramatically, and in some basins may even decrease slightly. But the proportion of intense and very intense storms is likely to rise. Warmer air holds more moisture, making extreme rainfall events during cyclones more probable. Fina, an early season storm that still managed to reach high intensity, is a concrete example of the kind of risk scientists have been warning about. Beyond the environment, Fina's relatively low human toll, aside from luck, came down to preparation. After the disaster of Cyclone Tracy in 1974, Darwin significantly upgraded its building standards, strengthening roofs, frames, and foundations. The city improved warning systems and invested heavily in public education about cyclone risk. When Fina approached, tough decisions were made early. The airport closed before winds became too dangerous. Public transport and supermarkets suspended operations, and evacuation centers opened in advance. This reduced the number of people out in exposed locations during the worst conditions. Many households already had basic emergency plans, stocking water and food, securing loose items, charging devices, and mentally preparing for blackouts and staying indoors. If you transpose a storm like Fina onto a poorer coastal area with fragile housing and weak warning systems, the story could have been very different. Hundreds or even thousands of casualties are possible under similar wind speeds. Fina shows clearly that the scale of a disaster doesn't depend only on the strength of the storm, but also on infrastructure quality, risk management, and community behavior beneath it. From Fina, we can extract several key lessons. Early warnings are only effective if people trust them and act. Preparedness must cover both the physical side, stronger buildings, supplies, shelters, and the psychological side, accepting that you may lose comfort, power, and mobility for a while, and staying calm. Critical infrastructure must be willing to shut down early, accepting short-term economic losses in exchange for fewer lives at risk. And in a changing climate, communities can no longer plan just for average seasons. They must factor in rare but high-impact scenarios like Fina. The core message is simple. You can't decide whether there will be a cyclone this year, but you can absolutely decide how prepared you and your community are when it arrives. If you live in a cyclone-prone area, ask yourself right now, do you actually know how your local warning system works? Does your household have a simple emergency plan that everyone understands? Do you know the difference between a watch, a warning, and a take shelter? Now alert. You don't need to be a meteorologist to survive a storm like Fina. You just need to respect the science, trust official warnings, and act early, before the wind starts screaming outside your window. If this video helped you understand cyclones and how to protect yourself, hit like, subscribe to Global Weather Disasters, and share it with friends or family who live in coastal or storm-prone regions. Cyclone Fina will likely be remembered as the night Darwin faced another major storm, but this time, the lessons from the past helped save many lives. Thanks for watching Global Weather Disasters. Stay informed, stay prepared, and we'll see you in the next storm.